Alrighty, I believe everything is set up. Hello, everybody on Patreon. Hello, the team members that might be watching this. I don't know if the team members do watch these, but I'm here. Hello, everybody. I am a new member of the Nodnin team, or I guess like a freelancer. I don't really know what my official position is, but I am here to help you guys understand a little bit about Unreal, change some things, update it from the Unity that the Nihmory project was in beforehand, and hopefully port it semi-competently over to Unreal while explaining my process so the devs or any devs that look back at this can understand what's going on in this little brain of mine, what the inner machinations might be hinting at. And it also allows them to, if there's any issues, backtrack and be like, oh, here's where this idiot decided to mess up the whole system. So let's just fix this little bit and move on. So for those of you that don't know me, I am Wyatt, also known as Lucid in some places. And yeah, let's just dive right into it. There's immediately some things that I do want to explain about Unreal Engine that might not have been very prevalent to any coding systems or engines that you've worked in, say Godot or Unity beforehand. Um, Unreal Engine works very core concept is trying to be able to give power to non-devs or computer science minded people. Try to give them the power and the same functionality that, say, somebody who has learned maybe 4 or 5 languages is and their capabilities are able to do. So what we did here is that Nihmory is, of course, a third-person project. Unreal has a lot of these great things. I can actually pull it up now. Ignore the background. Great background, but ignore that real quick. But I'll pull it up real quick just so I can show you all what we're cooking with in Unreal, what really kind of goes on in the process of this, and what you might see on startup of your Unreal Engine, in case you all want to just take a look at this. So when you load up Unreal, you have all these things here. You have like projects that you've worked on before. These are just a bunch of different stuff, and then obviously you see the Nihmory transfer from Unity to Unreal. So these are all just things I've messed around with kind of on and off for a few years, just trying to learn my way, feel my little feely feelers around, get my digits in there into the grime and muck and learn as much as I can. And so Unreal is able to do all these things, film, video, architecture, automotive, but we're obviously interested in the games. One great thing about Unreal is that they have templates that come along with it. You have a top-down perspective here. You have vehicles if you want to make a driving game, virtual reality. But obviously, for Nihmory, it is in essence, a third-person action-adventure game. So we started with the third-person blueprint here in order to sort of jumpstart our project. That way we don't have to worry as much about doing the nitty gritties, setting game modes, setting instances, implementing player movement, jumping, all this other stuff. That is all handled here, and it actually says it right here. If you look at the description of this, it tells you everything that you're getting, class type references. We have characters, spring arm component, game mode. We have all of this stuff, which is going to become prevalent later, as both I and you learn a little bit about each and every one of these little facets. But I just wanted to make sure that that is made known. This is what I did. I did set up a little third-person blueprint project here for anybody in the future that might need this devlog. Now, let us go back into the engine. And when you first load up the third-person blueprints, you are going to be loaded into this map, which is their third-person map. It's the testing area that you can just kind of mess around in and see what the basic gist of Unreal is going to be like. Now, if we load in here, I have done nothing to the controls yet. I haven't set these up or anything like that. And you can see already we have a nice little rotation of the camera. We can go all 360, up, down, all around. And then we can also move, jump, and you can see that we have animations for the mannequin. Obviously, for Nihmory, we are going to be having our own animations for the character movement and such. But this is what it gives you. This is the base set, the core of what Unreal is going to give you when you load up that third-person blueprint. You can see these blue objects. Give them a little kick. They're fun to play with. Uh, not gonna lie, kind of a time sink sometimes, but I mean, hey, they're really fun to mess with if you guys hit a rut in your development process. It's always nice to just kind of go into the third person, beta map thing. Just kind of kick these around. Kind of gets the frustration out a little bit. Obviously, little buggy. We're going to be making our own pushable, movable objects, so we're not going to be using the base movable objects that they have here. But nonetheless, still a little fun to mess with. And if you get it lodged in the corner, actually, you can... See? Alright. So, with that being said, what all does this give? You're talking about the blueprint methods, you're talking about there's not as much code. In fact, you can make a whole game without coding a single line of what's thought of as traditional code. Of course, there's ways that you can kind of override this. You can use C++, but it's not necessary. So, what it does is, let me just pull it up here. As you can see, I've been actually working in this project for a little bit. I've been mostly just implementing all of the meshes, all of the materials, all of the texture maps, and all that into this Nihmory content folder, so we all have it already. And honestly, the import process for Unreal is real simple. Let's actually find something that we can import, just so you guys get a little bit of an idea of what the import process looks like. We'll just make a little folder here. Actually, I think I have some models that are like default models for testing that we have here. So let me go and find those real quick. Here. Assets. And I believe this has some base models that we can just show you what the bring-ins look like. I think it's in prefabs? No. Come on, Lucid, you can figure this out. Ah, here we go. City. Okay, beautiful. So, if we go into the meshes, it's just where we're storing all of our static meshes. For those of you that don't know, static meshes are just a object in the world that does not have a skeleton, essentially. You can still move them, you can still tell them to go certain places with coding and all this other stuff, but in essence, they're just an object you can put into the world. You can change their dynamic ability and all this other stuff, and you can thus do a lot of fun things with them. So the base assets, I believe, are Quibbly. That's what it's called. And then for this, I'm going to just add a new folder, because this is the city folder. I have a lot of division when it comes to my organization. I like to keep things very compartmentalized and easy to find for anybody in the future, so hopefully that is understandable. And let's just bring one of these models here. I will pull it over to this screen so I can show you guys. As you can see, there's all these models here in this folder. Great, glorious choice abound, but we're of course just going to go with a basic bicycle here. If you pull this up, you can see that the bicycle has a few material instances. You can see the black, the blue, and it looks like the spokes are blue as well. We have a red reflector, and then the yellow frame. And so these materials are already loaded up onto the model. So what we are going to do is we're going to click, drag, boom. Simple as that. When you're importing a mesh of some sort, you are going to get this screen that pops up. There's a lot going on here. Don't worry. Don't freak out. It's easily able to just be broken down into little steps. So if I reset to default here, this is what you are going to see when you try to import anything. As you can see, nothing much really changed. The main changes that are going to be noticeable here is that there is not a combined mesh ticked. Now, if you remember when we pulled up the bicycle, like here, I can pull it up again. You can see that all of these colors are different kind of materials or parts of the bike. Now, what does that mean? It just means that basically in the actual file, the FBX here, these different model materials are technically entirely different components of the whole mesh together. So what we need to do, if you try to import that without doing a combined mesh tick box, it will break apart each color into its separate static mesh, thus making it to where you have to recombine them later on, and essentially it's a hassle. So this really streamlines the process and essentially brings all of those materials together, and you don't have to do as much work because, you know, that was what the 3D modeler's job was for. Why would you have to do more work as the coder? Exactly. So, with that all being done, we now go on to these. If you see, you can see there's a skeletal mesh here. If you are importing, say, a character model that has a skeletal mesh, you just tick that and it changes all these boxes. We'll get to that at a later date because I'm still fussing around with that. The skeletal meshes that I've tried to import aren't really importing right, so I think I'm going to look at a few videos and try to get back to you all on that tomorrow, hopefully. Maybe a couple days. I don't know how often these devlogs go up, as you can tell. But whenever the next devlog goes up, I will show you guys skeletal meshes, hopefully, and I will also have learned them, hopefully, to a competent degree, so we can all avoid making mistakes like that. Now going on down, we have build Nanite. Nanite is a system, well, first off, Nanite is a collision sort of system, along with, a specific rendering method that Unreal Engine itself used and made for its engine. What it is that Nanite is essentially supposed to make it to where super detailed, super beautiful environments can be made, but then Nanite uses this method in order to keep the texture quality while being able to render it on, you know, less intensive machines. You don't need a gaming computer, hopefully, to render, you know, say a forest. And that is what the idea behind Nanite is. I just tick it just because you don't have to use Nanite. Building the Nanite, I don't believe, hurts anything, but could be wrong. Generate missing collision, obviously, gives it a collision box. So it's nice to just do that. You can go in, edit collision boxes later on. Static mesh LOD group, leave it to none. Vertex import, like you don't need any of the color overrides, really. Generate light maps, that just obviously is the light map of the mesh. And you can pretty much leave all of this other stuff as normals. Now, where there is maybe another tick that you want to do and just check with your modelers with is if they have LODs. Now, I don't know what LOD specifically stands for. I think it means level of detail. Could be wrong. That's just what makes the most sense to me, but you know how acronyms are. Sometimes they're really funky. Essentially, LODs are different levels of detail that can change based on the distance away from the player. So, you just check with your modeler. If they have levels of detail, check that. If not, whatever. Even if it doesn't have LODs, I don't think that this really will hurt anything. It's just nice to leave it checked in case you can't get a hold of your modeler. Now, all these other things, you just kind of leave, convert scene, auto-compute LOD screen. Now, the only other thing that I would like to bring up is material. If you guys remember, we had, I think it was 4 materials for the bicycle. If you leave this on, it will create a new material instance for each of those materials that were shown in the bicycle model, and essentially it will populate them and just put them into this folder that you are already importing this into. So I would always just leave the material as local, because if there is a material in the folder using texture maps and all that stuff inside the folder that you're importing from, in theory, it is supposed to take that material, yoink, take those texture maps, yoinky doink, smack them together, and hopefully put it in here. Now, the issue with this is that we are importing from Unity, so all these assets are using Unity's .mat, which is not the same file type as the material instances in Unreal. So I don't believe this has worked for any of the Unity transfer. Oh, woe is me. I just have to go back and create materials for each and everything, which is fine. We have texture maps. You know, it's not a big deal. So if we hit import all, bada bing, bada boom, you can see the bicycle is here, and we have, oh, we have 5 materials, it looks like. Okay, so we have the 5 materials that it made. It's going to pop up with this screen. It's going to be like, hey, look at this. You have a bicycle now. And you have all the materials to go with it. So that's great. You're just going to X that out. And then this is going to give you some warnings. There's all sorts of warnings for different stuff. I don't believe that we can get a hold of a lot of the modelers for these because these are just like default like placeholder objects. But I wanted to make sure that I showed this for anybody in the future that might have issues with it. It'll be like, hey, no smoothing information. I believe, yeah. Please make sure to enable the smoothing groups option in the FBX exporter plugin before exporting the file, all this other stuff. Zero tangents, which can create some issues. It's just, these are probably issues that arise from the spokes, if I had to guess. Not entirely sure. I'm not the modeler. But I'm assuming that these are issues that arise from the spokes because they are very thin pieces of metal that are attaching to the bigger wheel. So, as you can see, we now have all this. Great, right? We can bring this in, boom, look at this bike, whoop, and now the bike is in the scene. But if we go in here, you can see, oh, well that's weird. Bikes don't stand. So there is some dynamic stuff that you will have to set up for certain objects. We will set that up. Hopefully, I don't think we're going to be able to set it up today. I don't think we're going to have the time. But you can see that, boom, you can stand on the bike. The bike has different materials. All this great, glorious, just beautiful stuff that Unreal does for you to take all the guesswork out. So that's how you import something. Very simple. Very straightforward. Of course, with skeletal meshes, we will get a little more in-depth, but as I said earlier, we'll tackle that issue at a later date. Because I don't really feel like dealing with that, because I obviously am not as knowledgeable as I thought I was, but future tutorials, I'll come back looking like a pro. We can all be happy, all learn together, and of course, see our favorite character meshes be imported seamlessly into the group. And see them walk around, move around, and come to life for you all. So, now with all that out of the way, how I imported all these files, all these meshes, all these other great things, we can finally get into the nitty-gritty of the code. So, as I said before, I like my compartmentalization. So, I have moved a lot of... When you first start the project, you obviously won't have this Nihmory content folder. You will have characters, level, prototyping, meshes, starter content, third person. It'll be all of the stuff in content and engine, except save. Nihmory content will be gone. That being said, in the third person folder, I have moved things around. So in the third person folder, we usually have this map, the third person map, and then you usually have another folder called Blueprint. No, not Blueprints, sorry. You usually have another folder called, can't think of it now. There is another folder in here. We'll get to that later. And then you also have this Blueprints folder, which holds the game mode. The game mode is pretty basic when you go in here. It's just basically you stating, hey, what is my pawn that I take control of at the beginning? What is the name of my controller that I use? What is the name of the state? All this other stuff. It's very simple. You, for the most part, don't need to look into this. There are sometimes, you know, obviously when you are changing the controller, when you're changing the game state, say if you have multiple different battle instances, or if you have like mini games, stuff like that, I believe that you can change all that just, you know, in the blueprint, but you shouldn't need to change the game mode here. You would be making a different game mode, change the controller in there, and then you just switch the game mode in the blueprints. So, nothing really that you have to worry about here. The real meat and potatoes of what we're going to be working in today is actually the other blueprint that I have moved out of here and into Nihmory content. So that is going to be found in player, and you'll see this BP third-person character. Now, where have we seen that before? It's in default pawn class. So that is what tells us that the player controller will take control of this BP third-person character at the start of play. That is all that it's saying. The default pawn class is what you take control of at the start of your game. So if you're doing a 2D game, you just make it a little sprite. If you do a top-down, you're obviously wanting it to be the top-down character. But top-down's a little weirder because I haven't exactly worked in it, so it might be a little bit different there. First person, obviously, you're wanting to be the, like, very close in your eyes sort of stuff. Now, with that done, if we open up BP third person character, which you can either do by just double clicking or, you know, I had it open in another tab already, you will see all this. What is this? So, when it comes to Godot, Unity, most other systems, Godot and Unity are just the other two engines that I've had experience in, but most other engines that I've seen require you to code everything line by line, just really knuckle down, grab a Monster Energy drink and hope for the best. But with Unreal, what are these? This is the blueprint editor, and where you will do a majority of your coding. Now, for those of you that do know C++, when you are starting the engine up, let me just actually go and show you. Hello there, Mirror B. Let me go and show you. If you do know C++, that is the coding language that Unreal Engine uses, and thus you can use C++ as opposed to this blueprint method. But blueprints are, in my opinion, much faster, much cleaner, much simpler to understand once you have wrapped your head around it. So that's why I prefer to use blueprints. It's not necessary. It's just kind of, you know, different styles for different fellas. But when you're going to start a project here, you can see in the project defaults under these templates, you can either do blueprint or C++. All you would have to do is tick C++, click create, bada bing, bada boom. You're off to the races. Now, with all that said, let us go into our blueprint third-person character, and I can just explain a little bit. I'm not going to be the best explanation for you all, so I'll try to keep these somewhat simple, and you can kind of look into it a little bit later on. But you start off with these 4 blocks of code, or 4 blueprints of code. And essentially what they are is setting up all of the inputs that we currently had. You remember we had the movement, camera, and then we could also jump. So, first things first, almost every single, and I'm talking about every single game, you are going to have a event begin play. Now, events just are things that trigger. Now, you can call events from each other. You can call events from an input. You can call events all sorts of different ways. Events are just how a line of code starts. Think of an event as the function line, the function call line and stuff. So you put like function movement input, and then you also want to set up like essentially when there is a movement input, it goes into that function, blah, 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 blah. I think I messed up, whatever. But these are the function call lines. These are what are happening. Now, additionally, we also have functions, which are separate entities. They are also blueprints, and it just kind of condenses and nicely cleans up your code. Kind of essentially the same thing, but functions, in quotes in this, are able to be placed anywhere. Events can only be placed once in a event graph. So, we'll just delete that function because we're not using it right now. Functions are multi-use functions, multiple places. You can call them from anywhere in these graphs. Events, one-time use, everything, I believe, has to be built off of the event itself. Now, you can still call an event. Say, if at the end of this, I wanted to call a movement input, we just put, well, actually, I don't think it can work here, due to the fact that these are specifically linked to the IMC, the Enhanced Input Mappings, but say I wanted to call another input, say I made like a custom event here, boom, and say it's like, for sake of brevity, this is not actually going to be the double jump, but see, we have a double jump event. If you wanted to call this double jump event, you just pull off of this executable pin, and then boom, double jump, call function, boom. And then when you start the game, the event double jump will be called. Obviously, we don't want to double jump right off the bat, so we'll just delete this. Now, what is going on in input mapping? Input mapping is what you call on event begin play, which is what runs as soon as the game begins, or as soon as this actor, which is BP third person character, it is a character class, which is, I believe, a class of actor. Bunch of random stuff. We'll get into that later. But it is when this actor is put into play, put into the space, this code will run. And what is it doing? It is getting the player controller, which is what in the game mode is what we are using for our inputs. It's our player controller. And it is grabbing just a controller. It's a pawn. It's essentially an object to represent what is going to be edited. And then as the player controller, it is assigning this mapping to it. If this subsystem is valid. Is valid is just saying like, hey, does this exist? Cool. If it exists, go on to the next step. So with that, it then adds the input mapping context, which is IMC default here, to the enhanced input local player subsystem. This is just a condensed line of code. That way you don't have to sit there and code through all of this default stuff that you have to do with every project, and it's mind-numbing, and it really turns people away from starting a new project, because it's gonna be like a whole day of just coding stuff that I've done 1,000 times before, done multiple times, and it's just there's gonna be debugging, because human brain go brrr. So it's just there to be like, hey, this is a block of code, we gave it to you, freebies, enjoy, take a nice little break, give your mind a nice little sip of water. And so that's all there. This is setting up the input mapping context, and it is essentially setting it to this one IMC default. Now, I remember what the other file that was in. The other file that was in third person was input. We're getting into that now. So that sparked a nice memory. So, the mapping context is in here. This stuff is given to you at the beginning of choosing your project template as well. It will change based on what template you choose. Say you chose a top-down, these input mapping things will be different and will do different things. No need to get into it. It's just pretty simple. Changes with your template. Now, if we go into here, what is this screen? This screen is a little weird, and it's kind of awkward, in my opinion. It's real awkward and kind of could be better explained, but it's simple if you really get into it. So this is taking input actions, aka if you have inputs and you press these buttons, it plays these actions. And so if we go back to the BP third person character, first we can see here, IA jump, IA move, IA look. That just stands for input action, and you can see that these are all linked up, spacebar, WASD, mouse. And then we also have mobile stuff. I don't think we're going to be doing mobile. Could be wrong, but we can get that out of there. It's just unnecessary. We can add it back later if needed. If you can see here, this is enhanced input action, so the enhanced input local player subsystem. And when you put in IA look, it does all these beautiful things. So it is getting the action that you get from the mouse, the 2D movement of your mouse, and inputting it into a 3D space, thus adding controller yaw, adding controller pitch, all that great stuff. Movement input, it's doing all this. It's taking the WASD that we saw here and transferring that into movement input here, which is just getting your rotation, the control rotation of your mouse, the look rotation, because this is setting the pitch and yaw. And so it's getting the pitch and yaw, saying like, oh, okay, you're facing this direction. If you press up, go that direction. It's doing all that beautiful work for you. And then the jump, simple. Press spacebar, you jump. Action's completed. Stop jumping. Now, this is something that we will have to work with a little bit later on. But for now, that's all you need to know. Jump is a basic function inside of Unreal itself. Jump adds a X value. I mean, not an X value. A Z value to your character. A Z velocity value to your character. So, yeah. It'll apply it. You don't have to worry too much about it. It's a basic function. I believe it comes from the character movement component. Could be wrong. But we'll get into all this stuff very quickly. So, yes. With that, I believe that explains all the base functions that are going on inside of here. So hopefully that alleviates some of the anxiety and stress that you get immediately from looking into Unreal. It's very simple, and it's nothing to be scared of. I promise. I was scared when I first looked at this. I looked at a few tutorials from a few different people, and instantly it just slowly started to click. So hopefully my explanation of stuff was at least sufficient. If not, I definitely recommend going to YouTube, just typing in like, "Hey, what is Unreal? What does this do? Why are things the way that things are?" And you will more than likely find a million and one explanations, probably 90% better than mine. But I figured I should at least explain it somewhat to people who might not understand what is going to be going on later on in the dev process. So, with that being said, what are we going to be working on today? We are going to be working on a couple of things from a checklist that I have made that are essential features from the Unity project that we need to now port into Unreal. So, with that, let us get to work. And the most easily implementable feature from the Unity project into Unreal is actually the double jump function. Now, recall we have a jump and a jump function, and the input action is already linked with it. Well, lucky for us, having that jump function also adds a little bit of ease to our abilities here. So if we type in jump max, if we select the BP third person character in the left side components here, and you type in jump max, you will find out that you can just change the maximum jump count that a player has. Crazy, right? So in that regard, we can just change that to 2. But if we compile and save this, by the way, compiling it commits it to the game. I don't know if I need to explain that. Hopefully that is something that is very common knowledge if you're going into game dev, but it is something that you do need to know. Compiling it commits it to the game, commits the changes that you have made to the blueprint. So if sometimes you make a change to the code and nothing happens, you might want to just make sure that you compiled it. And of course, save frequently. Compile and save frequently. Frequently, because just like any other game engine, Unreal does have a tendency to crash. And if you haven't saved in, say, 2 hours, that's a bummer. And I'll tell you right now, most of the time, your employer's not going to like that. Or you're not going to like it if you're just doing a solo indie dev thing. But if we go in, we change the max jump count. So now we can jump. We can double jump. But there's a slight issue. If you hold jump, ooh, we do not want this. Aya's going to be going off into the stratosphere. She's just going to fly on to the next planet. We do not want that. So, this is actually a pretty simple fix. It's not too bad. If we just close that out, go back to our third-person character. I believe that there is a... Hold on one second. Hold time. I believe that this might help. So, the max time the jump key can be held. Note that if stop jumping is not called before max jump hold time is reached, then the character will carry on receiving vertical velocity. So, we need best to call when jump input has ceased, such as button up event. So, a way to fix this is real simple. We can actually, I believe, call stop jumping here. And then thus, if we do all this, compile, save, I think that this will actually fix our issue. Nope. Now she just doesn't jump. Okay, so we have a little bit of a difference on that. I was really hoping that would be an easy fix, but there's multiple, just like drawing or writing, there's 101 ways to fix an issue that you might have. So, the jump function we are getting here is triggered off of any input that we are giving. So, if we go into our content browser, we can actually change, I think this is how I did it originally, but I was just messing around, seeing if we can do anything. So, we can see the triggers here. Now, if you don't have any of these set, it will just continuously trigger, I believe, until, It will continuously trigger until you stop holding the button down until the input is gone. So, if we just put pressed in here, I think that this might be a way to fix it. Hopefully. We will double check, obviously, because double jump is obviously a very important feature. Holding. So if I press and hold, she no longer double jumps. She would never, well, she double jumps, but she no longer floats off into the into infinity to go meet David Bowie and his people. So we can just do that, and now double jump is working. Simple as that. So first thing on the checklist for today, already done. Congrats, everybody. Get the confetti out. Start clapping. We have put in a good day's work. I'm just kidding. But yeah, see, now we can get up onto this and jump off into the ether. And Quinn, the model that Unreal gives you, will jump off and just disappear once it hits the plane that Unreal says, you know what, you shouldn't be here. So, with that done, let me go ahead and go over here and check off the double jump. Now, the next one that we are going to do that's actually pretty simple is the sprint button. So, we are going to start messing around with inputs and actions. So if you go into here, you can see we have input actions. This is just where all those IAs that you saw earlier are populated and just kind of sitting here waiting to be called, waiting for their name to come up. So we are going to do our own little input, into which you just right click, brings up this beautiful amalgamation of just confusion and disgust. And then you go down to these drop down boxes and you see input, and we're going to make our own input action, which is the same class as the ones to the that you already see here. So you can see the icon is the same. So if we do that and name it IA_sprint, go into here, you have consume on input, trigger when paused, reserve all mappings. You don't really need to do that. We just want it to be a Boolean. We want to press shift and say, are we running? Cool! Character run. So we just need to have the value type as a bool. As you can see, if we go into, we pull this up. By the way, for those of you wondering how this content browser gets pulled up, I probably should have explained this a lot earlier. You can either go down here, click content drawer and pull it up, or the hotkey for that is control space. Control space just pulls it up. It's like, hey, here's all the things in your project. Use them. It's great. It's fantastic. But if we go into this is a little more of a complex input action move. Not really, but I'll say it's complex. And all it is that it changed this to a axis 2D. It's like, hey, how much are you pressing in one way or the other? And thus it's like, boom, 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 boom. Hey, we're pressing this way, this hard. Go that way, that hard. It's really helpful for, obviously, movement. I think it's helpful for, like, looking and all that stuff as well. I'll double check. But yeah, see, look is also a 2D vector because your mouse can only detect two directions as it moves across your mouse mat. Sorry, my brain farted there. But yeah, it's great. Okay. So, with the IA sprint setup, make sure to save it. Always make sure to save. It's never bad when you can just save it and go on to the next thing. Okay, so we're in IMC default, which is our mapping context when we load up the game. And you see this little plus button, we're just going to smack that, and then we're going to bring this drop-down box down to IA sprint. Now, next we want to assign a key, an input of some sort, to activate the sprint. So that is going to be our keyboard, and it is going to be, where is shift? Is shift on here? No. Do we have shift? Where are you at? Good old shift. So we have left shift and right shift. Now you can go through this drop down box and do that anytime, but if you just click this keyboard and go boop, set. Now you can have as many inputs as you want, as many buttons as you want to mapped to this, and it'll be gloriously done, and it'll be fantastic, and you won't have to worry about a little thing. The only thing I will say is make sure that if you have overlapping contexts and all this other stuff, that you essentially, block one of the inputs out. That way, stuff doesn't get all wonky with you. So we're going to have two inputs here. I'm going to set this to either shift is going to have that. And give me just 1 second because I believe I actually have a graph to tell me all of the input commands that we need here. So we can actually set up most of our input commands and controls right now. And this is great for many different reasons. So let me just go ahead and take this out. I'm going to grab a controller. That way we can map those as well. And where did I put my controller? Oh, honey, no, no, no. It is lost. Gone forever. Okay. So I have found the controller. But now I need to find the wire. Oh, I am a mess. Oh, messy little Maximilian today. Ah! I cannot find it. I cannot. It's gone. Lost forever. Alright, I'll tell you what. I'm gonna go and steal, I'm going to go and steal a wire real quick, so bear with me real quick. I'm gonna pause the recording and I'll resume when I find the wire. Alright, I think that we're back. Hopefully we're back. Hopefully this is recording. It's gonna be tragic if it's not. But I have found a controller, so now we can add a couple more mapping inputs. So for sprint, we don't actually have anything in the dock. Oh no, we do have something in the dock to tell when to sprint. So we are going to do sprint to what looks like the right bumper to me. I will double check with our project lead later on and just double check that. But for now, let's set it to the right bumper. There we go. Gamepad, right shoulder. And then we don't have anything actually set to the thumbstick yet. But I do not know if that is going to change. For now, let's go ahead and set the sprint to the thumbstick as well. If you click in the thumbstick button, boom, your character's going to sprint. So, now that we have all of our input mappings, should be good. Thank you, Xbox, for having a beautiful controller. I love Xbox controllers so much. Alrighty. Now, with all that done, what does that even do? Well, adding the IA sprint button and the little input mapping context there gives us an event that we can use across any blueprint, across any section of the project that we want. And it can do anything you tell it to. It's great. I love enhanced mapping, and it's genuinely like just a beautiful thing that they decided to put this in. So we're going to pull out a new little function. By the way, this is another thing that I should have mentioned later on. You'll see me just pulling this menu up a lot. All you need to do to get this menu, right click. Sorry, I keep forgetting stuff like that. My brain just autopilots sometimes. But yes, you pull this up and you type in IA sprint, which is the name of the input action that we made. And then you see this little triggered function, and you just click that, drag out. And then I believe we want to get... Hold on. No. So, we have the character movement component, which comes based on every character when you start the class. And so, we want to grab this, drag it in here, and you'll see character movement component is now just a node here. But there's no execution. This is essentially just a variable. These little nodes with no pins coming off of them are just a little variable. See, it's a reference, an object reference. It's referencing this. Therefore, these two are equaling the same thing. Now, there are copies that you can get as well, which basically take that and duplicates it. But we're not going to worry about that yet. Just know that the reference and the copy are two separate things, and reference is going to directly affect whatever it is referencing. So, from there, we want to pull this off, and we want to set speed, set max walk speed. So, if you look into the character movement component real quick here, I believe it's in here, yes. Max walk speed right now is 500 centimeters per second, 5 meters per second. Pretty fast walk now that I think about it, damn. That's a real fast walk. Um, that being said, when you want to set this up, you want to make sure. Hold on, I'm just checking a couple things. We're probably going to change the jump velocity later on to better replicate that which is in the Unity project. I'm just making sure that all of this is fine. Swim speed, fly speed. Okay, we can check the rest of that later. But yes, the max walk speed is basically saying this is the fastest your character will ever go in this current state. So please, when it's going this fast, just know that that is a full-on input. Now, on keyboard and mouse, you can only ever have a Boolean input of a key. Is the key pressed? Is the key not pressed? So this will always be your walk speed on keyboard. This is what the equivalent walk speed on keyboard will always be. But if you look at minimum analog walk speed, this is the minimum that it will be. So when you're using a controller, this, say you barely tilt it at all, and he just like tiptoes forward like a little thief in the night. That's what minimum walk speed is going to be doing. So basically we want to make sure that when this is triggered, we want to set the maximum walk speed higher. So we're just going to go for 1,000, and then we're also going to print string real quick. Basically printing string is just to tell me, hey, this input was received. Congratulations. We're now moving faster. So let me just make sure to change this to sprint activated. Boom. And then when this is completed, we want to set, we need to pull off of character movement to get set max walk speed. Boom. Set max walk speed. And then the default that it is set to is 500, so we're just going to set this back down to 500 for now. Now you can do like different equations for all this, but it isn't necessary right now. We're just making sure that this is getting activated, and then thus after we're done deactivates. So we'll do sprint deactivated. Boom. Okay. Now if we compile and save, go into here, press space, you can see it's constantly activating. Therefore, it is constantly setting. Every time we do that, it is setting it. Boom, bang. So when we hold it down, it is activating the sprint. Therefore, it's reading, hey, there's an input. We should be going faster. Look at us zoom. And then when we release it, you can see sprint deactivated was sent, and it set our max walk speed back down. So you can see sprint is now working as intended. Now, there are some more nuances that we're going to need with this, but for now, this will do. So with that done, sprint capabilities is now in the game. Real simple. Real simple stuff. And if it wasn't for Unreal, genuinely, would take us much longer to get that set up. I'm just saying it right now. You're gonna think I'm an Unreal Engine shill, because I am. But genuinely, if you're looking to make a game from scratch, well, not really from scratch, because you're gonna be from a template. But if you have no coding experience, Unreal is the way to go, in my opinion. Please keep that in mind. It might change in the future, but as of right now, I think Unreal is the best place for non-coders to go to code an actual game. Not now, if there's like a visual novel you're making, there's other things. I think RimP is actually really good from what I've heard, but I've never used it myself, so take that with a grain of salt. Alrighty then. So with sprint implemented, we now want to implement some kind of stamina drain function, which means we now, one second, let me just check off sprint. We can change these these values later on to better reflect Nihmory's sprint speeds, but we'll just do that at a later date. Now, we want to be able to, let's see here. What's next on the agenda? You know what, let's set up the stamina. Stamina shouldn't be too bad. So, stamina, we're going to need a variable. This is new. It's something that has not been done for us yet in this blueprint. Variables are very powerful tools. It's just saying, hey, this is a number that's assigned to this name. Remember that. Oh, sorry. I burped a little bit, so I was just like, ooh. So if you're trying to set a variable, which most coding is, variables and the interactions between variables and functions and how they edit each other and what this variable is going to say to this variable, how this variable affects that variable. Variables are very, very important. So you are going to want to get to know variables inside, outside, up, down, all around, throughout, outwards, and back again. Take a little Bilbo Baggins Hobbit journey with this. But for those of you that already know variables, the way to create a variable in Unreal is you go into this little section to the bottom left here. Hopefully you can see my mouse. I think it's capturing mouse. And you just see variables, click plus, and there it goes. You got a new variable. You don't have to initialize this yourself. All you have to do is just click it and rename it, which for this we are doing stamina. Boom. And then we are going to be doing a float. Trying to think. I think float is the best idea. We could do integer for the stamina, but I think float is a better idea because then we can do percentages of your bar being depleted at a time. So I think I'm going to set float for now. Yeah. I think that's the way to go about it. So with that being said, boom, stamina is set. Now, if you're wanting to set a default value for the stamina, you just click onto it. You'll see the details in the right pop up. Then you just go down to the bottom and boom, implement 100 as the base stamina just because 100 is easy to work with. Very simple to see and, you know, it'll all be nice and kosher. Now, as is right now, Sprint isn't doing anything with this stamina. It's just not. So, what we actually want to do is create a function that drains the stamina when we... So, we want to create a function that drains the stamina while we are actively sprinting. And then, after that, at the end of that function, we want to call a separate function that thus regenerates our stamina as we are not sprinting or doing something goofy, you know, all this other stuff. So, what do we want to do for that? We're going to want to create a function because sprint isn't the only thing that's going to be draining our stamina. We have other things that we're going to implement, such as like wall running, I think is one concept that we want. We want hanging off of ledges, possibly hanging from a grapple. You know, attacks are going to take stamina. Jumping's going to take stamina. We want the stamina stat to also be writable to, like, say, a mount or all this other beautiful things that we have envisioned. Don't know if it's going to turn out perfectly as we envisioned, but we have all these beautiful things envisioned. So we don't want to create an event for just a solid stamina drain. We want to instead create a function. It is usable across many different events. And if you call an event, it'll call that function. Be like, I should be draining stamina right now. So with that being said, we're going to make a new function and just call this stamina drain. And I'm going to specify sprint. You don't have to specify sprint. It's just up to you if you want to. But we are going to more than likely have different drain rates based on the action that you're doing. So this is going to be the stamina drain for the sprint function. And with that, we want to get this, get stamina. And if it is being activated, we want to subtract the stamina. And then from that, we want to set stamina to this function, to this value that we now have. But if we load this in, you'll see a little bit of an issue. We're going to just go ahead and press, we'll just do one drain for every time it's called. And then we'll go ahead and print string and just connect stamina up. If you connect two variables that are not compatible, 9 times out of 10, it'll either say, hey, you can't connect it, or it'll convert it to the variable, then thus feed it in. It just depends on which variables you're trying to feed into each other. And so if we go into here, I have it set to print. And you'll see if we press sprint, nothing's printing because we didn't link it up. We did not link that up. Look at me being a silly Billy. Okay, so when this happens, you need to call into that. Boom. Compile, save. Now it should print. Boom. You can see it's rapidly draining our stamina. And it also goes down to 0. That's not, it goes past 0. We don't want that. We don't want it to go into the negatives. How are you going to have negative stamina? You're going to eventually die if this keeps up. You're going to get exhausted. And on top of that, we're not even moving. So, something's going on here. We don't want it to be a function that drains you when you're not moving. If you're standing still, you want to make sure that you're regaining your stamina back. So that's a simple function, fix. So if we go back into here, we can actually set a comparing function here. So if you right click on this node and break this link, and then we bring this back, we want to get the stamina amount, and then we want to check if stamina is greater than or equal to 0. No, greater than or... We just want to make sure that it's greater than 0. Sorry, scrap that. So back that out. So we want to make sure that stamina is greater than 0. If stamina is greater than the value 0.0, we are going to feed this into what is known as a branch. So branches are just essentially if-else statements. If stamina is greater than 0, do this bit, which is going to be setting stamina lower. Let me just go ahead and reorganize that. Boom. And then if stamina is less, or if stamina is not greater than 0, it just exits the function. Nothing happens here. So let's just compile and save every little bit and make sure that this works. So we go in here. We drain our stamina all the way to 0. No longer does it. It's feeding into the 0 function here now, into the false function. That's why it's not printing. And if we let go and press again, nothing happens. So we want to make sure that there is a stamina gain now as well. So if we go ahead and make, boom, a new function, call it stamina. I did not. New function, stamina. Whoops, I cannot type today. Gain. We are essentially going to set this equal to, okay, I'm trying to think, because we want a delta time mechanic, which I don't know if we can just get. Can we get delta time? Get delta time? I don't think that works. That's for animation. Get delta time. Get world delta seconds. Returns the frame delta time in seconds. Adjusted by time dilation. Okay. So let me just double check. Get. Returns the time span that represents. Okay. Trying to think for a little bit before we code this in, because there's a very specific thing going on here that we need to make sure that doesn't happen. We want to make sure that this is looped. So I think what we want to do is a while loop, and then with this, we're actually going to set a new variable. And the variable is going to be max stamina. Very simple. So now we have a stamina, which is current stamina, which I will update the name for, just to make sure that there's no confusion. Current stamina. And we also have max stamina. So current stamina is 100. Max stamina is default value. It's also going to be 100. So we want to compare these two together. So while max stamina, and then we want to get is not equal to current stamina. Feeds in here. Boom. And then we have a while loop. There is a function set as to where it terminates. It's when max stamina and current stamina equal each other. So with that, we want to set a delay real quick, because we want to make sure... Isn't there just a delay function? Hold on, they might have changed this in 5.1, because I used delays in 5.0, but I have not used them since 5.1 came out. So this is maybe a little goofy. Is there not a delay anymore? I thought there was a delay. Because I thought that I saw it, but I could be wrong. Let me double check in here. Okay, so delay is here. Why can this not be called in a function? Maybe it's because a function within a function, whatever. But I thought you could call functions within functions, because then I think you can call a stamina gain, yeah. So anyways, let's go ahead and see if we can do something here. Control C, can I just like paste this in here? No, it doesn't let me. Okay. Let me just double check how we can delay a function loop. Delay UE5. Wait, action delay specified seconds. Calling again while it is counting will be ignored. Okay, somebody has the exact question for us. Why can't I add a delay node to a function? Use collapsed nodes. Okay, so turns out we cannot do this inside of a function because delay just doesn't work inside of a function. So, that's nice to know. I apparently have never tried to use a delay inside of a function. So with that being said, scrap stamina gain, everybody. No longer doing that. And instead, we have to do it from the event graph, which is fine. It's just, you know, gonna clog up this blueprint, which is gonna get pretty clogged up as is. So instead, we are going to create a custom event here. Easier way to do this is just to do that, custom event, and this will be calling stamina gain instead. We need to delete this if we're going to call it stamina gain. Lol. Sorry about that. Why are we getting an error now? Okay, we're not getting an error. Beautiful. So, now we're just going to rebuild that. We're going to get current stamina, max stamina, pull this out, make a while loop, and then we're going to compare these two with a not equal function. Well, these are not equal. We want to put a slight delay in there. Delay. And beautiful. Hold on. I see a problem arising, but we'll just go ahead with this thought processes real quick to make sure that nothing, because it needs to break the loop before stamina gain, before max stamina and current stamina happen. But we'll figure that out in a little bit. We'll just make sure that we make a somewhat feasible function for the current stamina to regain, and then we'll figure that out later. So we're gonna go from here and add. And let's just make it regenerate 10. And then from there, we are going to set current stamina to that value after we add 10 in. Go here, print string, and then the variable is going into there. Beautiful. And so with this, it should always make sure to regenerate until it is not equal to current stamina. But we also have a little bit of an issue here because what if we start regenerating on a 7 or something? And so there's an issue with that to where we need to change this. I goofed. I goofed, everybody. No, I think that actually that can stay. We didn't feed it into here, though. So, instead of this print string, we forgot that we need to clamp the clamp float. Okay, so clamp float, basically what this is that it's going to take the current value of this, it's going to take current stamina, right? And it's going to be like, hey, are you above maximum stamina? If you add 10 and this is set to above what the maximum stamina is, 100, it'll instantly say, you're not above 100, you're at 100, you're at the max stamina cap now. So basically it takes any value that you feed in here and then it sets it within a range determined by the minimum and maximum here. So the minimum amount that stamina can ever have is 0. The maximum that it can ever have is max stamina. So therefore these variables should line up. And now we should be able to just print string and then set that all up again. Let's just see if this is all working because we obviously don't want to do too much stuff going on with it before we test everything. Okay, boom, we're draining and it is not going in because we didn't call it. Common theme here, if you guys notice. So when sorry, my brain just like short-circuited for a second there. So when this is completed, we're setting the max walk speed back down to 0, and then we're going to call the event stamina gain. All right, so this should work now. We have a problem. Infinite loop. Thought that was the issue. Okay. So the while loop is not working because we do have an infinite loop. Despite having a delay in there, it does infinitely loop because, you know, this stuff's going on here. So I'm trying to think of what the function could be. What we could do is set this up on a tick. I think what we're going to do is set up another variable. I think we're going to set this up onto event tick here. This should make things work out, I believe. So instead of doing it this way, we're going to just call it from an event tick. And so let's see here. We're going to pull out a sequence. So what a sequence does is it activates things in a sequence. So then 0 is the first thing that it checks. We are going to first check if sprinting. So for that, we need to create a new variable, is sprinting. For those of you that don't know what the variables are, we're going to set this as a Boolean. And a Boolean is basically two possible values that are activated here. It is just 0 and 1. Are we sprinting or are we not sprinting? So with that, we're going to drag this out. Get is sprinting. We're going to compile. So the default value we do want to be false because we aren't sprinting at the start. And we're going to go up into this and feed it into a branch. And so from there, we're going to be like, hey, every single tick that happens, every single second that passes, we want to check if we are sprinting. If we are sprinting, we are going to go into the sprint drain, stamina drain sprint function. Boom. And so it will drain the stamina every single time, and without fail, it will just keep draining, keep draining, keep draining, all that time. And thus, it'll constantly go into that function, which means that we do no longer have to call it here. And then we also don't want to call this. We don't need to call these anymore, because if we aren't sprinting, guess what? We just want to activate the event stamina gain. Whoop. All right. And so now what we want to do down here is just set these Boolean values. You can just do this instead. Whoop. Whoop. Okay. And one way around this, the reason that I decided to go with the event tick here is we can get rid of this while loop now, because delay is wonky. I don't know what's up with the delay. It just doesn't work as intended, I believe. So it is what it is. Instead, we're going to go with, we're going to give ourselves a little more space down here. Give ourselves just a tad more space. All right, and move this up. Move this to here. Alrighty. That should be a-okay. With that set, we now want to make sure, if we are sprinting, true, we want to make sure that while this is triggered, it sets this Boolean to true. And then when it's completed, when we stop sprinting, sets the Boolean to false. And that'll feed into here, to where it tells us which function to run while we're going and while we're not. I'm going to go ahead and promote this delta seconds to a variable as well, because it's just really nice to have. If I'm gonna be honest with you, having delta seconds as a variable that we can call kind of anywhere is pretty nice. What do I want here? Okay. So this is calling this every tick, which could get scary, but I think it's fine. And let's just go ahead and set these values down lower. Let's set it down to like 0.01, because now this is calling on tick, which means that it's going to drain super fast. Super fast. Which we just do not want. Okay, this is clamping. We're going to go ahead and put this down to 0.02. And this will start printing out every bit. We are now in a branch for the tick, which should be okay, meaning that we should print at the start. So we're going to get a bunch of messages here. Don't freak out. See, it's printing that it's at 100. And now, as we hold the sprint function, slowly going down. Boom, 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 boom. Granted, I set that way too low. It's essentially draining one stamina frame, which I think here is going to be... 0.01 stamina per frame, which is going to add up to, like, what, 0.3 a second? Which is not what we want. But as you can see, now we are gaining stamina back at about the same rate, a little bit faster on the stamina gain than the stamina drain. And we want to make sure that once it hits 100... Oh, we are now stuck at 100. So, stamina gain and stamina drain are now working. But we obviously do not want this whole function to be running all the time. So, we want to feed this into a branch. And we want that branch to compare the current and max stamina. And we'll do the not function again. That way it's not running that function every single frame if we have max stamina, because there's just no need for it. It's a high chance that eventually it could cause some performance issues and all that stuff. And granted, there's probably ways that you can optimize this, but I'm just setting it up the way that first came to my brain, which is using tick. You don't want to set too many events off of tick, because setting too many events off of tick is obviously going to get real intensive performance-wise, and it's going to require more and more, what you call it? It's going to require more and more resources from the computer, which you just don't want to have set up, preferably. Let me just double check to make sure that we are still good on the recording. Cool. So, if max stamina and current stamina do not equal each other, what are we going to do? Well, we're going to regenerate. But if they are equal to each other, the false is just break the function. You do not want that. What we can do is instead put a new boolean at max stamina. So, and then we can set this. True. So, if it's true that we're at max stamina, it sets that's true. And what we want to do is come up here. Go all the way out here. And then we're going to pull off of here and make another branch. Beautiful. So if we are at max stamina, we need to compile this. We want this to be broken. We want to break this link and go off of false into here. So if we're at max stamina and it's true, don't go any further. But if it's false, we're not at max stamina, guess what? You gotta check this. You gotta check if you need to drain or gain. So, with that being set, now it should at least stop. Once we're, see, you can see that it's no longer... Oh, we have an issue. Okay. Okay, I see what the issue is. No matter what, it's not going into the true. So that doesn't work. I'm an idiot. Don't listen to me. Okay. We can just have it set up this way and then have it, like, not worry about at max stamina. But it does mean that it calls this function, which is an issue. I just am scared that later on that it might become too resource intensive. Either way, it shouldn't print. Boom. We are not printing. We start draining, stop draining, prints up to 100, stops printing. That's showing that the functions are working as intended, at least. We also want to do a couple other checks. Because as is right now, you can see if we run off the cliff and we stop sprinting, we still gain our stamina back. We do not want to be able to gain our stamina back while we're falling, I would assume. That, or we want to gain it back at a decreased rate. So, to do that, we can just make a separate boolean is falling. Which I think might be a basic variable in here. Is falling. Yeah. So, this is a basic variable in here. We can just kind of branch this out. Whoop. Okay. We'll just save that there for now. And we're also going to clean this up so the lines aren't crossing. If you ever want to clean up your code, just double click on a line and it'll make these little like nodes here. It's just a way to help you better focus out where you want your code to sit and lie. Helps with the readability later on for anybody in your team that might need to read the code. So it's just nice to clean up your code that way every now and then. I try to make sure that after I code a section of something, I just kind of go back, mess around with it, go like, oh, you go here, you go there. Alrighty. Compile. Save. You come back down here. Just so I remember that I need to use you for something. Alrighty. And with that, I'm going to take a small break and grab some more water. So I'll be right back. I will pause the recording, and I'll see you guys in a little bit. Alrighty. I believe we should be back, and we are going to, first off, I'm going to just make sure to hit save all, because I don't think we have done that at all during this project. It's just nice to make sure that we do that every now and then. We're going to set this up a little more to 0.5. That'll probably be a little too fast, but like I've been saying, we can kind of mess with these and figure them out as we go. We don't need to be too greatly worried about it. What are we going to do? Alrighty. So, one thing that we need to do that I've forgotten to do is really simple. We need to get current stamina. And off of the jump function, we want to set the current stamina. But, you know what? Let's not cloud this up more. Let's just do stamina drain jump. Let's make sure to have these as separate functions. It just is nicer. It keeps everything nice and clean. And if you ever need to look into the function, you can just come in here and look at it. So, stamina drain jump is going to take current stamina. How much do we want jump to drain? Let's see. We wanted to ask if it is greater than the stamina drain of the jump. For now, let's just make jump cost 10. I think that jump costing 10 is more than okay. We want to feed this into a branch and go there. Now, if we have more than 10 stamina, we want the jump to go out, and it wants to get the stamina. So we're going to go ahead and get another stamina here. Get, and we want to subtract 10 from it. Boop. And then from there, we want to set current stamina again. Yes. Actually, we don't need this now that I think about it. We don't need that. Because the better way to do it is to check the stamina before the jump happens. So, if I do it that way, then we shouldn't have any part where you, for some reason, are able to jump when you're not supposed to. So instead, we are going to take this into a branch. Whoop. Just go ahead and give us some more space here. Whoop. And take this down. Okay, now we're going to put the comparative right here, which is going to ask, you know, the whole, is stamina greater than 10? Greater than 10. Boom. I'm just gonna, a way that I like to organize stuff, if it's, you know, in a compact format like this, is I like putting the variables just like right on top of what the function is that they're getting called into. It's just something that I enjoy. Some people might not like it. Just letting you know that ahead of time, anybody who may watch. If you see stuff like this, it just means that this is going to be fed into the thing right below it. If you are seeing stacked variables on top of comparators, functions, stuff like that. It's just a way to kind of bunch it all together, make stuff more compact. That way, we're not taking up as much space and hopefully not bloating the, what you call it, bloating the blueprint, because making sure that it is readable is one of the most important things. And then we're going to do the stamina drain jump. Bang. Okay. Now, I'm just trying to think here. There is a bug that's going to happen. I already know there's a bug that's going to happen. Where we do that. And see, we can drain jump multiple times and thus causes issues. And we're also gaining stamina on the fall, which we don't want. Which is why we made this up here. So we are going to do is sprinting, if false, stamina gain. No. What we want to do is break this. So if is sprinting is false, we want to additionally check, hey, are we falling? And so from this false, we are going to implement a new branch. And for sake of compacting everything, just put the character movement on top of here. Whoop. And now from this, we're going to be like, hey, are we falling? And if it's true, we don't go anywhere. But if that is also false, if this second check is false, we now gain stamina. So now, this should at least fix the stamina gain issue. But as you can see, we're double jumping, but we're draining a lot more than we should be. So we're at 100 right now. You should only ever be able to drain 20 stamina from a double jump. But if I spam click it, say I'm in a fight and I'm scared, you know, I don't have faculties, you can see that I spam clicked it 8 times before I landed, and I landed with 20 stamina. So that kind of has an issue there. We are draining more than we should. Now, there's multiple ways that you can check that and make it stop. We're basically going to have a check in stamina drain jump here. And what I want to do is there a remaining jumps? I don't know if there's a remaining jumps, because there's like get jump, current jump count. Okay, so we can compare the jump current count and jump max count. Tracks the current number of jumps performed. Yeah, okay. So we can get these two and compare the two. Easy. Whoop. So, get jump. Oh, that's not how you spell jump. Grab that. And get jump. Max count. And then we want to check if these are not equal. If these are not equal to each other, then we... Whoops. I'm going to bring this up here. We want to put it into a branch. Now, if they are not equal to each other, guess what? We drain. Simple as that. Guess what? I'm going to stack these two because I am addicted to compartmentalizing everything and making my code readable. Like that. All right. If this is false, if they are equal to each other, essentially, don't do anything. You don't need to. There's no reason for it. Compile those. Now, we should be able to see, we jump once, 90, jump twice, 80 is where we started there. Now, if we spam jump it, you can see we still only had an 80. So that fixes that bug. So jumping and double jumping are now fully done, should be fully done. The stamina drain on them is fine, and then if we're falling, it does not regain our stamina. We can set it to a different stamina gain while falling. We just have to set up a variable for that, like falling stamina gain. Or a separate function, maybe. But that is a process for later on, after I get an actual, like, after I check to see if that is the case, if we want to do that or not. Why does it keep saying 40 items are unsaved? Weird. But yeah, for now, this is all set up and done. We're just going to move this down into here. That way it's closer. Compact. Compact, compact, compact. Always make code readable. You know how it is. The game dev's ultimate journey is not just to make the code work. You also want to make sure that anybody on your team who might need to read this code later, might need to read the blueprints later, you want to make sure that they also are able to tell what you're doing. It's a great thing. If you're ever in a team setting, that is one of the main things that they are always checking. Can we read your code? So, that is one of my biggest things. Make sure to make your code readable, guys. Anybody can code a game with a little bit of knowledge and patience, but if you can code a game and make it to where others understand what the frick you're even saying in the code, then you're hireable. Let me tell you. Alrighty. With that, jump is done. Now, we come down to this beast, this dragon, this metaphorical, mythical being that we have to discuss here. So currently the stamina gain is stopping, but we have a little bit of an issue if I'm not mistaken. Actually, do we? Trying to think. So, yes, there is an issue. When we're standing still, it is stamina draining. We don't want that. How are we exerting anything? We're just holding the button down. We shouldn't be draining. We're not getting exhausted from this. So, we want to fix that. We want to get the current velocity, I think it's velocity that we want here. And we want to compare it to... So... Trying to make sure that I get this right. I'm going to go ahead and make another variable yet again. I know, I'm addicted to making variables. But we want to get a base walk speed here, because this will make stuff much easier, in my opinion, to understand. And so for the base walk speed, right now it is set to 500. So we're going to go ahead and set this to 500. And if we go back to the event graph and speed, now when we're done sprinting, we can actually just set that. Base walk speed. Boom. And so now it is always going to set to this, no matter what. And we can make another variable for the sprint speed, but I don't want to make too many variables. This is going to get filled with variables either way because of attack damage, health. You got to think of all these other floats that we're making. So you don't want to make this too bloated. You want to try and cut down and just do variables that are kind of necessary. Granted, there's probably easier ways to do this, so you know. So stamina drain sprint. What are we doing here? First off, we want to check if we're even going fast enough. So the first bit is we're going to bring this branch out. Because if this branch is here, you know. Hold on 1 second. Let me just check here. So it's setting. I'm just trying to think logistically if this is going to cause any issues. I don't think so. But we want to get the character, speed. We don't want to get character speed. Oh, crap. What am I doing? Velocity? Is it speed? No. Speed. Oh, this is going to be... I think what we're going to do is we need a reference to self. Is it velocity? It's something like this. Get velocity. And we want to normalize this. No, we don't want to normalize it. Oh, what am I doing? We want to convert this to just a float. We want to set this to a float. But it's not doing that. I'm trying to remember. Because we have the velocity component, right? We can split this struct pin, which gives us the value of each one. We want to check if both of these are equal to 0. So, okay, I think I have an idea of how to do this. Branch. So we're gonna branch this out. If I stay this, okay, we want to check both of these. If this is greater than 0, or y is greater than 0. So we want to feed this into an OR Boolean. So if either of these are true, if either of these values that we return from x, the velocity here, are greater than 0, then essentially what we are going to do is we're going to feed this in. If either of these are true, we go up there. So we're going to put these here, just, you know, clean it up as we go, because it's a lot better if we just get in the habit of doing this. I know, wow. Good place to go. All right. So now we should have this all set up. That being said, sometimes logistically your brain does not work it out the same way that the computer thinks it should work out. So let's just double check to see if this is working. I'm holding sprint now. It's not working, but if I move forward, looks like it's draining. And then if I stop holding sprint, instantly starts. Beautiful. Okay, so we also have the jump going. What if I go off this? Okay, hold on 1 second. Let me check something real quick. We go off, boom, 32. Okay, that's still working as intended. And it doesn't seem to be draining while we're falling, so that's all set up right, proper, and good. Ah, fantastic. All right, now on to the next bit. There is one thing that I would like. So right now, if you stop sprinting, it automatically starts the game again, right? It automatically starts it up. We don't really want that. We want a little bit of a delay here. So what we're gonna do is set that up. Now, how do we do that? I think what we want is down here on the is sprinting, we just add a delay. Hopefully this works. I could be wrong. This might not work, but I think this will work out the way that I'm intending. So let's just go ahead and set it on a 1 second delay. As always, this might change a little later on. Move this down so it doesn't get caught up there with that. And let me just go ahead and save all. Boom. And see, now there's a slight delay before it starts regaining your stamina. So we go sprinting, da-da-da-da-da, da-da-da-da-da-da-da, and boom. 15.5, there's a 1 second delay, and then it goes, you should start regaining now, because you have that. Okay. Now, there is a slight issue, I believe. Hold on. Oh, no. Okay. So the first check is sprinting, so that is what I was worried about. If the first check was falling, then the issue was that if you stopped sprinting, guess what? You automatically start regaining because it was checking falling. But since we set this up in a way that actually benefited us later on, thankfully, it was not actually intended, it worked out fine. So, with that, I believe the stamina gain and loss is now worked out for both sprinting and jumping. Yay! Congratulations! Nihmory is slowly one step closer to getting done. Alrighty. So the sprint is all set up, the stamina is set up, and with that, let's see where we can get to next. Let's go ahead. Give me a second here. Let us set up a... Actually, I do want to check something before we go. Before we move on to the next step. I want to check if movement inputs and all that is working here. Which, for some reason... Oh, I need to click in. Okay. Oh my god, the camera movement for the control... I'm just checking to see if it works on controller. My bumpers are a little bit wonky, so they might have a little bit of issue. The jump works. Okay, it seems that the jump isn't working, the double jump isn't working for controller. Oh, there's something interesting on controller here. Okay. The controller has a bug. So, let's check out the input mappings. I don't believe I set this to... Yep, okay. So it's just when pressed. And that should fix that, I believe. Let's double check, make sure to save everything. Hopefully now the controller... Alright. Beautiful. Sprint is working there. Sprint is working there. Alright. And with that, it looks like even the controller is working now. Alrighty. Sweet. I'm actually really happy about that. Alrighty, we can set up, I would love to set up attacks, but the issue is that we need the skeletons set for that. So we can't quite do it yet. Not until I figure out the skeletons. Let's see here. Let's go ahead and exit out of that. Alrighty. Give me a second here, guys. I'm just checking some stuff to see what we could do next. Excuse me. Let's see. Let me check, because it might be a case of Unreal's animation blueprints for Quinn might have an attack animation. So, does Quinn blueprint... You know what? Since we do not have anything until we get the skeletal stuff situated, how about the next dev part that we do is something a little more interesting? We'll go ahead and fix up some materials, because the materials are actually pretty easy. So if we go into character models, you can see that we have Aloy set to green here. And that's because Aloy is actually already finished. Aloy's skeletal mesh, which, you know, is a little little scary. His skeleton is a little messed up, but as you can see, Aloy is actually already set up. He has his colors all set in here, and he's ready to go, right? He has his two-sided cape. Everything's working out pretty okay. But that's not how it always was. I had to set up these materials. So what we're going to do is actually go into a Vander, which I specifically did not do. 1 second. Let me just check this. Yeah, so this is weird. This is what happens when you import skeletal meshes. But, luckily we can still do the materials, without too much hassle. We have the materials in a separate folder. So once we get the actual, like, skeletal mesh situation figured out, we should be okay and able to, just import these materials onto the next, onto these again instead of the mesh. So, what I like to do when I'm setting up meshes, I like to always have this buddy. I like to regenerate. No. So as you can see, he has hair, eyes, body mat. This guy is not loading. Look at what I've done. Combined mesh T-pose, combined mesh. Is this it? Is this the one that I need to pull up? Okay. So, he has, this is what he looks like to begin with. Not great, right? Looking kind of pale. Clothes not there, and he's also got a little bit of issue. If you look very closely, he's kind of clipping out of reality on the insides of his clothes. So, there is a couple things that are really easy fixes. I believe the clipping out of reality is as simple as, I don't know if it's on here or not, but we just check for two-sided. It's not on here. We go to, sure. Bind mesh. Where is the two-sided? There should be a function, not a function, but like a check to see if it's two-sided. This is the animations. It wouldn't be in here. It should be in here, I believe. Weird. Because I remember checking two-sided. This is literally how I did it for Aloy. And now I'm like, huh. Well, guess two-sided isn't here. Let me check Aloy real quick. Because Aloy I had to go through, his cape wasn't loading, and I had to check two-sided for him. I believe it is on his skeletal mesh. Ew. Is it on the skeleton? I'm going crazy. What? Aww? Going crazy. Shouldn't be this. Ah! I think it is in the material. Sorry about that. Let me check. Let me just double check the material real quick. Body. Two-sided. Okay. It's in the material. It's not on the mesh. Common mistake. Ha! Very common mistake, you know. Okay, so we gotta double check which mesh is linked to his clothes, which I'm assuming would be the body mat. Could be wrong. And then, therefore, the hair and the eyes do not need to be two-sided, though I probably should make the hair two-sided, just to make sure that, because he does have some under area here. Doesn't look like he's clipping out of existence on his under area on his hair. But it might be best just to check that just in case. I don't see any clipping on Evander here. Oh, nope, I do. Right along this side of the face. You can see that he's clipping just a tad. But it's enough to bother me. And so, it's a very easy fix. We'll just go ahead and make that. The eyes shouldn't need it. The reason you don't want to set two-sided for everything is the rendering amount. It is harder to render two-sided materials. So therefore, you don't want to set everything to two-sided if not needed. Just quick little save on materials. You know, you want to save where you can. That way it's better for them. So, what are we going to do? When we imported these in, we were given all of these beautiful little materials here that correspond to these here. Now, the issue is that this is not my naming scheme. This is just like naming scheme that Unreal came up with. I don't like this, but, you know, your naming schemes are your own. I'm going to go ahead and rename these to m_body. There we go. Thank you. And then this is going to be m_hair. The reason I just like having the type of file at the beginning. That way, if I don't remember the exact one that I need, I can just type in M or Matt at the beginning, and it can just search through it, and like they're all in nice order. It's just easier for my brain, and obviously everybody has their own naming schemes. Just go with what you want, what you feel. It's not really that important. Just making sure that everything stays consistent in the naming schemes so they don't get lost is pretty vital. But I have multiple checks for that, so shouldn't be too much of a hassle. So let's go ahead and make sure that we set that to two-sided already. So get this out of here. We don't need that. So when you pull up a material, you are brought to this screen. This is a pretty minimalist screen, and you can see like we have emissive color, anisotropy, base color, metallic, specular roughness, tangents, normals, world position, offsets, ambient occlusion. This is all words that are very artfully inclined and can be confusing to some. Don't worry, it's actually pretty simple. So I'll break it down. If we go into the hair folder, we have these little things. What the heck are these disgusting creatures that we see here? Well, it's actually pretty simple. These are actually what we're going to be plugging in. So if you see here, we have something called the diffuse map. These are all called texture maps. These are all just different textures compressed down to a nice little square, which is, in this case, 2048 by 2048. Pretty big, actually. Depending on the game, textures dimensions might be bigger, might be lower, but this is just basically UV maps, texture maps, that unwrap the model of the character and place them in a square, so you can just, when you go to create the character in a engine, in, say, a different modeling program, it'll take each part and just wrap a square around them and thus create the character seamlessly again. So each of these have their own little, their own little functions. And it's pretty simple. If you have texture maps from your modeler, you won't have to worry about this too much. There's a lot that you can go and do here, but from here we have our texture maps from our modelers, so it's pretty easily. So the diffuse maps are pretty simple. Diffuse maps are pretty much going to be used as the base color maps. So you're going to want to plug the diffuse map in there, and then automatically it's going to update this material on the viewport in the left here. And look at that, it automatically updates. So this is Evander's little hair circle that we're getting when we wrap the diffuse map around it. But we have a bunch of other stuff going on here. We have a glossy map, we have a height map, we have a normal map, and we also have an AO, which is short for ambient occlusion map. So we're going to have to plug all these into their different positions and make sure that they're all working right. So what we're going to start off with is the base color and the normal maps. These are typically the two most important maps. There is an issue with Unreal sometimes. Most of the time, Unreal, when you import these normal maps, it will be like, oh, this is a normal map. I will set it to a normal map, which you can see in compression settings. It says normal map there, which it doesn't say it here. It just says compression settings default here. So if your normal maps are not working, make sure to check the normal map and make sure the compression settings are set to normal map. If it's not, I believe you can just go in here and there's a way to set it to a normal map. Create texture, right? Convert virtual texture. And I believe, I don't know. I'd have to double check, but there is a way to convert the normal maps over. I would just have to re-look into it, because for the most part, 99% of the time, if a texture is vastly like this bluish color here, this bluish purple pinkish color, 90% of the time, 99% of the time, Unreal's going to be like, oh, that's a normal map. That being said, this can sometimes work counterintuitively. If you have a blue color that you're trying to set as your base map, and it's got a lot of blues, purples, pinks, stuff like that, Unreal might also counterintuitively be like, oh, that's a normal map, where you intend it to be a diffuse or base color map. So just something to be aware of. Make sure that you check your maps and make sure that everything is set up the way it's going and what it needs to be set as, and so everything hopefully gets applied to what needs to be applied. But for the most part, Unreal will handle it. It's just an extra thing that you gotta kind of be on top of if you import your textures. So the normal maps, obviously, you're gonna take the RGB node, click it into normal. Is this the ambient occlusion map I just pulled? I just kind of autopiloted, and then I was like, wait, I need to actually explain what's going on here. Okay, so for these maps, they're pretty simple. You're gonna plug them in, obviously, where their textures say they need to be plugged in. So this is the ambient occlusion map. You guessed right, it goes into ambient occlusion. Boom. All right, and now here's where it gets weird. So we have a height map and a glossiness map. Now, in Unity, I believe glossiness is its own subset of like the texture qualities, like a texture parameter. That's what the word I was looking for. But in this, Unreal doesn't have glossiness. So you're like, well, where the heck do I put the glossiness, Obviously, this isn't just supposed to be, base hair with no shine, sheen, or shimmer. Because if you do that, look, it looks too plastic almost. It looks like a little army figure. You have these shines here, but that's on the actual color. The color's changing, but there's nothing reflecting. So that's where the glossiness is supposed to come in. But the thing is that Unreal changed glossiness to metallic. So metallicness of a shader is actually what the glossiness is. But if I put this in, you can see, well, first off, I need to apply it. Sorry. Let me apply this real quick. You'll notice, oh, well, this is weird. Because now the parts that are supposed to be shining kind of just are not shining. And the parts that aren't supposed to be shining are kind of shining. That's because Unreal also inverts them. Because with metallic, you want to invert the maps. I don't know the exact reasoning behind it. That's something for the Unreal developers, the engine developers. But a quick fix around it is if you have a glossiness map, say you're transporting something over from Unity to Unreal, you just do a 1- node, pick it up, feed it in, and it should fix the glossiness on it. See, that looks way more glossy now. It looks like hair that is actually, a little bit greased up. And then we go back in here, and it should, yeah. It looks much better. Looks definitely glossier. Looks like hair. Granted, stylized hair, but hair. And if we can check real quick here, it looks as though... Let me just turn this down. It looks as though it has fixed that part. I just wanted to check to make sure that the hair was being double-sided. And it does appear that that is what is happening. So I think that we are good on the double-sided stuff for the hair material. We will keep a watch on that, but it might change in the future. So now the other material that I need to make is the double-sided, is the body material. Because that is the other part that's clipping and really breaking the immersion. Granted, it's going to be hard to notice it because it is like you have to get up in Evander's face to get in here. But if you look at his joints, yeah, it's a lot more noticeable. So we're going to have to fix that. And it is as simple as clicking that two-sided once again. So now that we see that the hair is working, we used all these maps. Before we head out of here, now, don't take my word for this, because I'm not 100% sure on it. I could very well be wrong on this one in specifically. The rest of these maps are where they need to be. But the height map is included in a lot of these. And I could be wrong, but when I see height map, I think either roughness, which is not what I believe is where it goes, or pixel depth offset. So I believe that the height map might be the pixel depth offset. I could be wrong. This is something that I'm gonna have to, like, double check. But I believe that this tells where the pixels need to be deeper, higher, and all this other stuff to kind of give the illusion of depth to it, and essentially make it look like there's crevices in the hair and stuff like that. I could be wrong. I don't know for sure. But for his hair, we're going to go ahead and do that. And see, with that, his hair should pretty much be done. Ooh. What is going on there? Is that my... Oh, you know what? I think that... Okay, I think I know what's going on here. So I think that on the body mesh, we're going to see sort of a brown spot on the body mesh somewhere to kind of fit this hair color. And what's going to happen is that it's going to fill this in and be like shaved sides. Okay, so don't worry too much about that. All right, and with that, the hair is all plugged in. Like I said, the height map might not be where it belongs. I've looked and searched for Unreal Engine's documentation on where to put height maps, and for some reason, for some ungodly reason, nobody's asking that question that I can see. There's people asking it, but it's saying to pump it into base color somehow. I can't figure out how to pump it in the base color. If I figure it out before the next devlog, I will be sure to let you all know. But obviously, it's something for another time. So I apologize. Hope that you guys understand and that we can still move forward from this and continue to develop this beautiful game. Would you like to apply the changes of modified material to the original material? Yes. Didn't we do that? Oh well. I think we did that already, but never harm in doing it a second time. So we're going to go ahead and do the body one because the eyes, I believe, are going to get a little... Hold on, let me see if the eyes are going to get funky. Yes, so the eyes are going to get a little funky because of this emissive texture. We'll get to that. Emissiveness is fun. It can add a lot of character depth to the actual art. So, we'll get to there. Oh, I forgot that these things exist. So, I love looking at unfolded humans because they are just the most terrifying abominations. But, anyways. We're gonna pull these out and we're gonna go about the same process of just linking them into the same parts. Diffuse goes to base color. Boom, all those go in there. We'll just go ahead and hit apply and see if everything's loading right. Boom. You can see he is set up, but he is a little bit flat. Now I want to check this. Okay, so maybe there is an issue that I need to fix with the hair. We will figure that out. There might be a little bit of a hair issue, but I didn't realize that they had the tongue modeled. Anyways. I get sidetracked, okay? I get sidetracked. Just leave me alone. I noticed something when we were over here. We do need to click on M-body and make sure that this is two-sided. Beautiful. And now, what else do we have to... Oh. Why are you doing that? Why are you doing that? Stop it. Stop it, you. Bring this open. Okay. Oh, we actually have some emissiveness on the body here. So never mind. We're going to have some fun already. You guys are in for a nice little treat. Okay, so next we're going to do glossiness since that is just the next one up. We're going to go ahead and 1-. Set that into there. And we're just going to go ahead and spread these out. That way, we can have somewhat of a logical setup here. Because, geez, do these materials get confusing if you don't have them set up in a readable manner. Okay. So next we're gonna go ahead and do the normals and the opacity. Oh, we have opacity. Okay, beautiful, 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 beautiful. We can show you a few interesting things here. So we're gonna go ahead and pull out the maps that we already know. Normal map. Let's just double check that this is a normal. Beautiful. And we're gonna plug this into normal here. I missed. Beautiful. Next, we need the ambient occlusion map, which we didn't... I don't think we had an ambient occlusion on the other one, but ambient occlusion, I believe, is just for, like, helping with certain little, yeah, self-shadowing, the crevices. Yeah, it's just like, hey, this is behind that, that's behind this. Make sure that everything winds up a-okay, and make sure that, there's no confusion as to what is in front of who. Okay, so that's set up. Next we have height map, which we are going to set into the pixel depth offset. Bring this out, height. All right. So if we apply this now, give it a second to work, you can see that now Evander has got his glossed up body. He's looking nice and spiffed out. He's a little too glossy on this. I don't know what this is. Maybe this is a satin material. Oh yeah, this looks fancy. This is probably a satinish material, so that's probably why it's so glossy. But yeah, he's looking nice. He's looking all clean, put together. His eyes aren't in his sockets, but that's because we have another material that we have to set up. I still think he's looking a little too glossy. I'll have to look at the sheet here, because this looks a bit too glossy from what I remember, but I could just be remembering things wrong. And let's double check the sleeves, which it looks like they are keeping together now. Yep, looks like they're keeping together. There is some issues. Oh, hold on. Yeah, okay. I see an issue here. I don't know if that's a fault of the model or not. I could be wrong. I'm gonna have to bring that up to somebody. This might be a fault of the model where it seems like at the seam of this shirt, it is kind of not really tearing, but since these two aren't flush with each other, see the band there isn't flush with the like connecting part of the shirt, the cuff isn't flush with the shirt. It's kind of just has this empty area here that's ambiguous as to whether it should have faces or not. So it's causing this weird situation where, like, yes, this is double-sided, so it's kind of clearing out and making sure that this is a cylinder rather than a face that you can't see, but it's also making it to where the bandages are appearing where they shouldn't be on the other side, so that might be a bug we have to fix later on. I will make sure to check that out. But in the meantime, let us work with the emissiveness, because I love working with emissiveness. So, emissive and opacity. Let's do opacity first. It's pretty simple. So usually when you get an opacity texture, what it's going to do is it's going to be pretty much a white box with these, like, well, there's not much in this that you can see, but let me go ahead and maximize it. You can see here that it's pretty much a white box, and then you have this here, which is a gray box determining where the opacity on the diffuse map, or just the material in general, is supposed to be. So this opacity is saying that this part that doesn't have a texture, it looks like, should be kind of clear. So because of that, that's not what I meant to do. Because of that, that is what is considered as a mask. So if we go to blend mode, this is asking how we're going to blend everything. And if you don't have any opacity, you just want to render it as an opaque model, just because quicker to render, easier to render, less performance, all this other stuff that we've been making clear. But since this is a mask, we want to do masked. And so when I clicked masked, you notice that this opened up. I'll go ahead and switch it back just so you can see. If I click opaque, both the opacities are grayed out. Thus, they're not being used. But if I click masked, opacity mask opens up. And what you want to do is you just want to take this opacity mask, take the RGB, and you guessed it, plug it right in there. And that should set up the opacity for it, which I'm not sure where this opacity is. But if I had to guess, yep, it's the bottles. Bottles are now clear here, which are a little too clear in my opinion. But I think the point is that that mask is supposed to pretty much make them clear, because you can see a little bit, I think, if I'm not mistaken. Yeah, there's a little bit of a shade difference with the opacity on that. But it is a little hard to tell. So I might need to look into that and see if there's a way to kind of make that opacity a little bit less less transparent. So with that all set, our last bit is the emissiveness, which is fun. So trying to think, where is the emissiveness set up at? The emissiveness is that liquid in the bottles. Okay. So, trying to think here. Because we need to multiply, right? That's the issue. It's auto-saving. Great function from Unreal Engine as the autosave. It does try its hardest to make sure that your progress is not lost. So, what do we need to do here? Let me just pull up Alloy, because emissiveness is something somewhat new that I've learned. So I want to pull up Alloy's textures to make sure that I did this right. So Alloy, I am lerping this, which is a linear interpolate, which is just essentially like, hey, it's going from base color to this color. But I think I'm actually supposed to multiply, so let's take that off and multiply. Am I wrong? Isn't this supposed to be multiplying? Let's check. I think I'm actually supposed to be multiplying there. Yeah, I'm pretty sure that's what I was supposed to do, because these parts are much brighter now. Could be wrong. But I'm pretty sure I'm supposed to multiply on that, not lerp. So we're gonna leave that there. It's looking better in my opinion. We'll just leave it for now. We'll change it if it needs to later on, but I'm 90% sure it's a multiply, not a lerp. I don't know why. I think this was the first emissive texture I did. So what we can do, I think I have a model set up with an emissive texture. I just want to make sure I'm doing it right. I don't want to give you guys misinformation on the internet, you know? Go into meshes. Wow, no. Where did I put you all? Monsters aren't done yet either. Let's go to renew. I thought I did another emissive texture. Oh, I did emissive texture on Aya's eyes. That's what it was. Yeah, because this is set up right. Okay. So, it is a lerp, and we used this, it looks like. Because we used it for Aya's tattoos. So yeah, it looks like we want to linearly interpolate, and essentially you want to make a multiply layer that makes this emit a green. I believe it's green. I need to get the base colors for this. Hello there, Aya. You look so gorgeous today. Have we ever told you that? Look at that beautiful face. Look at you. Okay. So it is a lerp. I was wrong. I am an idiot and a fool and a charlatan in sheep's clothing. So, what we are going to do here... What was I doing? Body. Emissive. Boop. So we got this here, right? And therefore, we need to get a lerp, which is a linear interpolate. All this really does is it takes a value from A to B, and it essentially... this graph is a mask showing it how far along that curve to go. If you do not have a value set for A, which should be what you call it? Should be base color, I believe. If A is not specified, it's just not showing. And then if the color is chosen, it should get slowly closer to that emissive color. But see, most of this is black, so it's just not emissive at all. The only part that should be emissive is the color that is masked. So what you can do is just use a diffuse mask and bring that in here, and it should only make the vials emissive, in theory. Let me find the vials. Where's the vials? I'm not going to find the vial. Oh, there it is. See, this is the emissive vial, and you can see it's kind of got a glowy feel to it. There's something about it. Let's go ahead and take this out. Break this link. See, it is not glowy anymore. So, you just run that back in. Bada bing, bada boom. And it is now emissive. Now, the reason we have to plug it into B is that A is basically the 0 value. You wanted to go from 0 to whatever colors are mapped to these sections. So, and then this is determining what sections are mapped. And that's the basic thing of it. If you were to misplace this in here, and it goes from 0 to, you know, this, it would make everything emissive, except for the vials. And obviously that's not what Evander wants. We don't want our boy to glow like the radiant sun. No. We just want him to emit a little bit of a glow on these vials here, which they are now doing. See, they're our brighter value, and they are glowing just a tad, which I don't know if that's going to bother me or not. I feel like I should be figuring something out for the vials, because the vials have like a weird cutoff on the cylinder. I might be nitpicking myself here, but I feel like that is something that is not supposed to be happening. But, oh well. With that, the body material of Evander should be done. He is a little bit glossy. I need to figure out why that is, and we will figure that out eventually. But let's go into body here. And so we are going to save. And the last material we have to work with is his eyes. Now, the eyes are interesting because the eyes' textures are very specific regions. So, let me go ahead and close out the body material, pull this up, open the eye material. And it is second verse, same as the first. We're just going to plug all these in where they belong. Just give me 1 second here as I do just that. Here's the glossiness. Don't forget the 1 minus. Go into the metallic. Alrighty. Now, he does have emissive color on his eyes as well. His eyes glow. They're so beautiful. I can't help it. They're just so gorgeous. We do have a normal map. The normal map here is a little funky. I don't think this is going to cause any issues. Bang. Alrighty. Height map. We need to go down here. Oop. Whoop. Pixel depth. Did it have? It does have ambient occlusion. Why do the eyes have ambient occlusion? I don't know, but I'm gonna set it up because that's what I'm told to do. I don't quite understand why the eyes have self-shading, but, you know. Sometimes in this world, you don't ask why. You just know that it needs to be done, and you say, aye, aye, Cap. It's going in. 10 seconds of my life, oh well. And then the last bit is the emissive, which, once again, we are going to send into a linear interpolate, or LERP for short. That's not where you go. I'm going to take that down, break this link, and then we're going to get a duplicate of the diffuse map, which you can just click and then hit Control D, which will duplicate the node, and you can go there. That is one thing that I feel like I need to do better of, is that I use a lot of hotkeys when I'm doing this. I should make sure to let you guys know when I'm using those hotkeys, and as you can see now, with the emissive texture, his eyes glow a little bit. So, that purple eye from his heterochromia is now just a bit more characteristic and has a bit more adding to him. So with that, with all these done, if we apply here, this should be Evander's completed mesh. And with that, Evander's completed mesh is now fully set up with its materials, and he looks pretty freaking snazzy, if I do say so myself. That's how you set up a material in Unreal Engine. Pretty easy, pretty quick and forward, quick and simple. If you don't have, when you get the character made, the modeler should always send you the texture maps. If you're making it yourself, you can UV unfolding. That's a whole thing for a different time. But if everything is done correctly, it should be pretty simple and straightforward like this. I believe with that, all three of the characters that we need right now are actually materialed up. I think the materials are all done for them. So that means we can move on to inorganic materials, which are along the same lines. They're pretty much the same exact song and dance. But what we can do here instead, go to weapons. You see we have a few different things going on here. The bow and the sides kind of had the same materials. If we go into the bow crystal, we have all this going on. If we go into metal, we have black metal M, which I really want to rename because I did not rename that. M black underscore black metal. And this is Evander's weapons that we're making here, which we don't have made yet because they are just using as close as it could get to it. M underscore Evander weapon crystal. I need to be more specific with my names or else these are going to get lost when I pull them up later on. I am always for being more specific. Alright, because these are all different materials. So, with that being said, close. Pull this back up, and then we're going to pull up this scythe with the feather combo. So this is what this is the weapon that this material is assigned to. This scythe here, which it is actually a bow. If I can pull up the other one. This is the bow of it. So you can see here, he has like a little feather hanging off. Little like talisman of sorts. And when connected, these two sides make this beautiful little bow here. So what we're going to do is we're going to set up this material for the scythe first. And then obviously we have a little bit of a gap that we need because these sides are not identical. So we need to make two separate materials for the metal with the feather and then the metal without. Or maybe it's the feather's connected to the crystal. No, the feather is connected to the metal. So hopefully we have the texture maps for both the metals. We might not, but we will see. So let's get on with that. Go ahead and do that. And I will also show you how to change materials, because as you can tell, this material is not set. So I will show you how to change the materials once we get these materials set up. Shall we? Boop, boop, boop. And pull this open. So as you can see, when this was loaded in, I can actually show you the example of this. Boop. Let me go to the actual file. Oh, I don't remember actually which one. I think it's resources. It's not there. Freak out. Time to freak out. I think I know how to do this. This. We want to find... Okay, never mind. I'm dumb. I don't remember what the source file is for this. Enemies. Okay, enemies. Vander. Bowmats. Okay, here we go. So, I'm going to pull up the Evander Scythe with Feather combined here. So if we pull this up, you see that these two colors are what's equipped on here, right? This very dark black and this purplish looking stuff that is the, in quotes, crystal part of it. So what Unreal does is these are the two regions that the materials relate to. The black is all one region and then the purple is all one region. But Unreal reads this as, oh, these are the two colors that these are supposed to have. So when it makes the materials, it will try to make them as these colors if these colors are stated in the file. So that is the issue that we are having here, is that it's thinking that these two are what is necessary for the file, and therefore it is trying to make these close to it, but that is not the actual colors that we want. So we want to actually set up these different colors with the texture maps that we got from our modeler. Which is, and metal, this is metal, right? Evander black metal. Okay, cool. So, if we pull the metal UV out, this is very straightforward. It's just in the diffuse. Put that there. And you can see we have like a bunch of stuff going on here. And then we pull out the emissive. And then we need to linear interpolate. This only has 2 texture maps. Am I stupid? Am I missing something here? Might be missing something here. I think I might have missed something when I transferred the files over. This should have more texture maps, I think. I think it should at least have a normal map, if I'm not mistaken. But for now, let's not worry about that. Let's just get this all set up and make sure that we got done what we can do. And we can't worry too much about what we can't do, guys. Alrighty. And with that, if we hit apply, this should now update. And look, we now have feathers and stuff, and we have, see, we should be having, okay, we have a little issue with the feathers not appearing on one side. That's simple enough. We can just set this to a 2-sided. But yeah, we're having an issue. We should have an opacity mask at the very least. So I'm going to have to root around in the files and find the opacity for the feathers here. But as you can see, the metal has now got these blemishes, and it's got all this weird grossness along the handle. It's got like a dirt layer almost. So it's got all these imperfections that makes metal look more metallic. And despite all that, we are missing the metallic layer, the glossy layer, and the opacity, but we can figure that out later. For now, let's go ahead and pop back in here and fix that 2-sided real quick, which should make that function correctly. Just check that. Yep, and now we have the feathers on both sides. You can mess around with the physics, get this UV right here to be like a physics, essentially, and make this function separately from the bow. I'll look more into that later if we want to go that into detail, but I don't think it's necessary right now. This is the first devlog that I'm doing, and so let's just keep things pretty simple, shall we? I'll make sure to save. Alrighty. I'm already out of water again, guys. But I'm a trooper. I can do this. Okay, let's go here. Make sure to take out the base color that Unreal automatically set. Grab the crystal color. Swip into the base color. And then the emissive color is all that's left. Yeah, I definitely feel like we are missing some important parts. I will ask the project lead about that. And see if we can clear some things up. Because I think that there's supposed to be stuff going on there. Let's grab a lerp node. Switch this in there. Go into emissive color. Ooh, that's pretty. Alrighty, let's see how that looks. Smack it on there. Oh, yeah. That's what I'm talking about. Look at that freaking scythe. Sheesh. Too bad. Too bad there's a little bit of a drawback of these feathers taking me out of it. But that is looking pretty nice, if I do say so myself. Good work to the modeler. This looks freaking sick. And now the scythe for Vander, for this one at least, is done. So, we're going to go over here, save. And now we have to figure out, because I don't think that this is going to work out properly, but we might as well try it and see what happens. We're going to go ahead and clear. We're going to see if this fixes up how I'm wanting it. I highly doubt it due to the fact that it's different sizes, but we want black metal. No, it's not going to line up right here. Because you... Ah, that was the wrong place to put that either way. Black metal. Yeah, you can see it's very stretched. It's not setting it to what it needs to be set to. So this texture is something that I need to bring up as well. Hold on. Maybe not. Nah, it looks a little off. Hold on. Let me just put the crystal in. Oh no, maybe it's fine. Oh wow, I'm surprised. I did not expect that did not expect that. Huh. Well, lucky us, we don't have to worry too much. That just loaded up correctly. So if you ever download a model and you tell it not to set the materials, don't worry. It still typically will make the spots on the regions on the item that it needs. And instead you can just go into the item's mesh, the static mesh, and you can just select these and you can set the materials. And as you can see, it worked out perfectly here. So now we have a Vander's bow. And that's pretty much all you need to know about materials. There are some cases, if we go back into here. That's scary. Okay, cool. You will see roughness is a thing that is typically pretty dominant with different structural components of things. It usually just determines how worn something looks, how for lack of a better terms, how rough something is. It's not supposed to be smooth. It's supposed to have dimples and crevices where it's been weathered over time. So roughness maps are pretty typical to add to different environmental things. We already showed off the opacity. There's sometimes just straight up an opacity texture, which I believe you can just go And is it translucent or additive? Translucent changes the opacity to that. So obviously most of the time we are going to be using opaque. Sometimes we're going to be using mask. It just depends. Whatever your texture maps call for. Specular isn't used very often. It's just not needed really. Because I think that metallic kind of phases out specularity, if I'm not mistaken. I could be wrong, but specular you can pretty much not worry about too much. There's very rare cases where you'll get specularity maps. You just plug them in there, and it should be cuckoo cachoo. Other than that, pretty much everything here is just like if you mouse over it, it'll tell you what you need, and you can go from there. Alrighty. And with that, materials are now explained. Is there anything else that I should explain before I close off this devlog and say goodbye to you all? How about... No, we can cover UI next time. I don't think we need to go into the user widgets and all that stuff, because user widgets are a big problem. It's not a problem. It's a big part to digest. And I wouldn't want to spring that on anybody for the first time that they are watching an Unreal Engine, like devlog of any sort. It is just a little bit much. But, let's see here. Is there anything quick I can explain? Not really. All right. Well, with that, I am going to continue the very lengthy process of setting up materials for pretty much everything I imported that you guys have seen so far, and kind of get everything situated and combined and worked out, and hopefully get all that done today. It's going to be a long process, and I think that what I'm going to do is I'm going to end this recording, and at the end of this we might have a time lapse of just me setting up a bunch of different materials, and we might give you guys just a little look at that. But thank you guys so much for coming out and enjoying the devlog. Hopefully you learned a thing or two. Hopefully this also makes it very clear to the other members of the team that end up looking at this code what I was doing. I will go back and comment on them. For those of you that don't know what commenting is, it's just a way to basically state in the blueprint what happened, what this bit of code is doing. So I will go back and put some comments in there so any team members that look at this in the future can easily determine, even without watching the devlogs, hopefully, what each bit of code does. But until the next devlog that you guys see, thank you all so much, and I hope you have a wonderful rest of your days. Bye-bye!